Hi everyone. I just thought I'd do a really quick video on using your GDC to solve calculus kind of problems. So what I thought I might do is just create a brand new document and add a calculator to it, so we're ready to go. And I thought I might tackle the question that was in the quiz. Now the question was, find the equation of the tangent to the curve y equals 4x cubed minus 7x plus 2 at the point where x equals 2. So I thought instead we might find the equation of the normal to the curve just to add an extra step. And this is how we'd go about doing it. First of all, I'm going to use my define a function thing in the calculator to put in that function. So we use the colon equals or control, and then there's the colon equals there in blue. And then we just type in the function. So that's 4x cubed minus 7x, 4x cubed minus 7x, and then it's plus 2. And the colon equals means it's now defined. If I go f1 of x, that'll tell me what it is, 4x cubed minus 7x plus 1. And if I go f1 of 2, then that would be 20, etc. The next thing I'm going to do straight away is I'm going to define, because I know I'm going to be needing the gradient function, so I'm going to have to find the derivative. I know you could do this by hand, it's not that hard, but I'm just doing it for the sake of it, is I'm going to define the second function, f2, as the gradient function of f1. And you can do it through the menus, but I'm going to just hit the control button. No, I'm not. I always make that mistake. I'm going to hit this button here underneath the blue colon equals, and that brings up a whole bunch of different kinds of functions, including fractions and roots. But the one I'm interested in now is the d by d something, this one here. That's our derivative one. So I'll click on that. Oops, I forgot my equal sign here. So it'll be colon equals. And then I'm differentiating with respect to x, put the x there. And what I'm differentiating is, you just put f1 of x there. I'm differentiating this function with respect to x, and that will give me the derivative. So f2 is now the derivative. You can stop the video and work it out manually if you like it in your head and see whether you get it. And f2 of x is 12x squared minus 7, as you would expect. 4 3s are 12x minus 7. So that's fine, and I can interrogate that as well by putting f2 of a number. Now the question said, find the equation, well I'm changing a bit, of the normal to the curve at the point where x equals 2. So I'm going to go and work out what the y coordinate is at x equals 2. So I'm looking at f1 of x because that is our original, our OG graph. And I'm looking at what is the value of y when x equals 2. So that's f1 of 2, and I get 20. Okay, so then I'd write that down. 2, 20 is my coordinate point, because that coordinate point of the original function is also going to be a coordinate point of the normal. The next thing is I need to work out what the gradient is at x equals 2. Now, if I go f1 of 2, sorry, f2 of 2, f2 being the gradient function, then 41 is the value of the gradient at that point. But I'm going to do the normal instead. And probably the easiest way to do the normal is to go minus 1 divided by, and then type in f2 of 2. So negative 1 divided by is like that, flipping the gradient on its head and making it the opposite sign. So m1 times m2 equals negative 1, so that takes care of that. And then that's the gradient of the tangent. So that gives me negative 0.002439. So that's my gradient. So what I would do then, and I'll stop the video here so it's not too long, but what I would do then is I would then take this value here as m, and I would write into my, I would write this down, not put it into my calculator. I'm just doing this just so you can sort of see it. I would go y minus, let me see now, what was y? 20. Y minus 20 equals negative 0.02439. X minus, and then what was x2? And then I would use my calculator to turn this into mx plus c format, or you could just leave it like this and it would be legitimate too. That's basically it. This bit is the normal gradient at the point 20, or 2, 20. Hope that all makes sense.